Okay, we're talking panel degradation. You got a project coming up. What panel do you choose? Valley here from Greenwood. Today we're continuing on our panel spreadsheet series of presentations. This week we're looking at a range of panels and comparing apples with apples. So if you like what you see, hit that subscription button. Let's get started. In the panel degradation spreadsheet presentation, and see the link, we concluded with the following. So we were looking at a 400 kilowatt system. We selected a panel with a particular degradation profile and looked at the 25-year accumulated savings based on some assumptions. And they were like 25 cents per kilowatt hour cost of electricity, with a 3% increase in electricity pricing and the maintenance cost increasing every year. So in this presentation, we'll be looking at the following. We're going to compare accumulated savings between a number of panels, and we're going to do this using a data table from the what-if analysis function in Excel. And we're going to examine some other metrics that will allow you to make the best decision in regards to what is the best panel for your needs. By looking at a range of panel options out there, the installer designer can compare overall production data savings for a 20 to 25 year period and look at the dollar savings per watt installed and the total cost of the solar panel component of the project. So obviously there's a relationship between all these factors, and you've got to have the ability to compare apples with apples. Now we've got to do the following. We're gonna set up a table that compares the outputs of all the panels under consideration. Then we look at the total savings for each panel, and then we look at the various ratios that will help with the decision-making process in regards to the best panel again. So we have a table here of various panels ranging from RIA to ACME, and we have year 20, 21, 22, 23, 24 and year 25, and then the accumulated total kilowatt hours produced, okay? So this was derived in Excel, and we can see the top figure of 12,498,188 kilowatt hours. That's over a 25-year period, and that's for both RIA and SunPower P. So the difference between the largest production number and the smallest is 568,050 kilowatt hours. So here in this particular table, we are looking at, again, panels all the way from RIA to ACME, and we are looking at the total savings. The panel that has the largest total savings or panels is the RIA and the SunPower, and the Panastronic has the lowest, as you can see here. And the difference between the largest saving number and the smallest is a figure of $87,064. So we're talking dollars here. Now in this slide we're looking at the best total savings, and we can see that there are 3 panels that are at the top of the list in regards to total savings, and they also happen to be the most expensive per watt. That's not always the case, but the best 25-year savings per watt value is at $4.78. Price for the panels alone are $212,000 for the SunP, $232,000 for the Longo, and $232,000 also for the Trima. This is the question. The best total savings come from the panels with the highest dollar watt price. So overall project price is higher, assuming other material installation costs are the same, regardless of panel price. Also, as mentioned, the difference between the best and worst savings over a 25-year period is $87,000.64. So what do you do? How do you make the best decision? What are you going to base your best decision on? we're looking at the 20 to 25 year best savings panel price ratio. And we can see that there are 3 panels that are at the top of the list in regards to the saving panel price ratio. And they also happen to be the cheapest per watt, and that makes sense. And vary in regards to their 25-year savings per watt. So the prices for the panels alone are $176,000 for the Solaris, $184,000 for the Acme, and $180,000 for the Soluna. For example, let's say we select the Acme panel, which is the second best savings panel price ratio compared to the Solaris, but total 25-year savings of, $1.893 million compared to $1.825 million, right? So this is a difference of $62,000. But the cost to you for the panels alone is $8,000 more, okay? A commercial solar proposition is presented as a financial option for the target business. So as a designer and installer, you must have all the pertinent data at your disposal, so correct decisions can be made. Now, when there's a range of panels on offer with different degradation rates and prices, what metric do you choose? But to be able to even ask that question, you need data. And this is what this whole presentation is about, the ability to analyse that data between different panels. So good luck on your next solar project. Thanks for watching our presentation on the comparison between different panels, the best panel for your next commercial solar project. I'm Veli from Greenwood. Hit that subscription button if you want to see more of these presentations, and if you've got any questions, any inquiries, any answers, please get in contact with us. See you next time.